the rate, yes? Since you are doubling the concentration, that's the one that has the exponent. And then you look at what happened to the rate. If the rate stayed the same, then what's the order? Zeroth order. If the rate doubled, what's the order?
Second order.
First order. 2 to the first power is 2. If the rate quadrupled, what's the order? Second. Okay? I mean, that's it. If you don't understand that yet, I'm not enjoying you being in my class. Okay? You're going to pay for the consequences. So, now if I have first order, how does the first order rate law look like? No, don't look in your notes. Just look into my eyes. What? No, that's called integrated rate law. I want
just
the
rate
rate
law.
law.
Okay, for first order, R is equal to K constant times
R is equal to K.
times the initial.
Concentration raised to the first power. Yes? This is first order. Second order? Times the concentration of A raised to the
Squared.
second power. And zeroth order, this is the order in which I like it,
Yeah, me too.
is equal to K raised to what power?
0.
Zeroth power, which means any
1.
number raised to the zeroth power is equal to 1, yes? And we're still going to write it in there.
Yeah.
So, my question is, what are the units for the rate constant for each of those? Do it. I want the units for each of the rate constants. Why are you looking to the paper next to you? Talking to you, Ms. Rodriguez.
Just seeing what you have.
Okay, good. What do you do, guys? You solve for K, yes? Do you not? If you solve for K, R, it's on the other side, will be divided by what? By the concentration. This is the concentration of A raised to the first power. What are the units on R? Molarity per second. I'm going to leave it like that and I am going to divide, okay? This is like divide. I just do it separately. Divide by the concentration of A, which is in molarity. So molarity cancels out with molarity. And the units on first order rate constant are seconds to the -1 or inverse seconds.
Yeah.
Yes or no?
Mm-hmm.
The units
Yes.
this is R is molarity per second still. And this one is molarity squared.
You end up with 1 over
So that cancels out with 1 over.
seconds and meters.
And what you have is molarity to the -1 and seconds to the -1. And what is it for this one down here? This is R divided by A to the 0th power. So this is molarity per second divided by molarity to the 0th power. This is 1, yes? So units on this are molarity inverse second or molarity per second. Why do we need to know that? How is that important?
So in the problem you can see like which order it is right away.
Yeah, I'm not gonna tell you what order it is in the problem. Okay, you have to look at the problem, and if I give you the rate constant, with the units of the rate constant, that's what order you know it is. Okay? So I am not going to give you the order. You have to know based on the units.
And to know if it's like between the rate constant and the other one.
What do you mean?
How do I explain this? If it's the integrated rate law or the rate law or the half-life, like what do you say on the problem, like half-life or?
Yeah, we'll do those.
Okay.
It takes a while.
All right.
Guys, is that clear? Raise your hand if you understood that I'm not giving you the order of the reaction and you have to know from the rate constant. Raise your hand if you understand that. And the ones that didn't raise their hand, are you in this class still, or are you just like to go against, what is it, authority? Mr. Capote, you did not understand that?
I want to slow down the class, I could just figure it out by looking at it.
No, there's nothing to figure out. It's only what I tell you. The order of the reaction, right? You need to know if something is first order, second order, or zeroth order, yes or no?
Mm-hmm.
The only way to know it on the test is by looking at the units on the rate constant. This is called rate constant, yes? This is the rate constant. On the test, I'm gonna give you stuff, okay? And I am not gonna tell you what order it is. You have to look at the units. If the units are inverse time, what order is that?
First order.
First order. If the units have molarity to the -1 and seconds to the -1, what order is that? Second order. And molarity per second, the units are for zeroth order. Yes or no?
Mm-hmm.
I know some of you still did not hear that. Let's do some problems. You want some problems?
Yeah.
You have been dying to do problems, haven't you?
Three.
So, I want the rate of disappearance of O3. Why do I use the word disappearance for O3?
It's a reactant.
Because O3 is a reactant, and what is it doing? It is being converted into a product, yes? So it's not like it's disappearing as an act of magic, okay? It's just going away.
So unique
Yeah.
rate law.
No, this is not rate law. This is about what? Rate of disappearance and a rate of appearance, okay? So what we are going to do is there is a difference between rate of disappearance and rate of appearance and the unique rate law, on the unique rate. So let's do the rate, the unique rate. So what is it for this?
1/2.
1/2, positive or negative?
Negative.
Negative 1/2, changing concentration of O3 divided by the change in time. Do you agree, yes or no?
Yes.
Yes. Okay, that's what that is for O3. Let's do it for O2. What is it?
1/3 positive.
1 divided by 3, change in concentration of O2 divided by the change
Change in
in
temperature. Or time.
temperature, no, in time. Okay, what's that called? This is called the unique rate, yes?
Mm-hmm.
Now, what I gave you was not the unique rate. Yes? What I gave you was what?
Zero
Yeah,
is wrong.
it's-
What I gave you was the rate of appearance. That's what I gave you. How much it appeared. Of course, how many times did it appear? 3 times, yes?
Mhm.
This has a 3 inside of it, yes or no? So, this number is 6.0 times 10 to the minus 5 molarity per second. Okay? So, what do I need to do to this number? Okay? If I wanted this, the rate of disappearance, if I wanted the unique rate, what would I do with this number?
Divided by
I divide by 3, yes? If I divide by 3, what do I get? The unique rate.
Mhm.
Yes or no? If I had this number, what would I need to divide it by?
2.
By 2 to get the unique rate, yes?
Yep.
Because this is disappearing appearing 3 times as fast, yes or no?
Okay.
So what we are going to do is, since I have this number, and I want this number, I want to get rid of this number here, yes? I want to leave this by itself. I want this to look like this. 03 divided by that, okay? And what I have on the other side is, I already have 1/3 change in concentration of O2 divided by the change in time, yes?
So you're bringing the 1/2
This is
over.
going to stay here, but 1/2 is here. What do I need to do to get rid of it?
Multiply.
I multiply on the other side by 2.
Uh-huh.
So instead of this, it will be 2 divided by 3 times that, and that will give you the change in concentration. Now, the change will be negative times the negative will give you something that is positive, yes?
Mhm.
We don't worry about the sign, because all the rates need to be what sign? Positive, yes? So, this is like this. And what am I gonna call this? I am calling this rate of disappearance, yes? Is equal to 2 divided by 3 times
Times
6.0
okay.
times 10 to the minus 5 molarity per second. What does that give you? This gives you 4.0 times 10 to the minus 5 molarity per second. So whenever the rate of disappearance or the rate of appearance is given to you, is it called the unique rate? No. It has that coefficient in it, right? So you have to divide by the coefficient, yes or no?
Okay.
Tell me, why is this through here?
Because of the coefficient in front of
To make it what? Yes, I know it's because of the coefficient, but this, I divide the rate of, what is it, appearance by the 3 to make it what? To make it the unique rate. But then I don't want it to be the unique rate anymore. I want it to be how much of this disappears. What do I have to do? I have to multiply the unique rate by that number. Yes? The unique rate, have all of them have that coefficient divided by it. Yes? So if you don't want the coefficient, what do? You multiply by it.
That's cool.
Calculate the rate law. When you go to the lab, you make me proud, okay? Next week you're gonna have this in the lab. Calculate the rate law, the rate constant, and the rate. At concentration of A equal to 0.050 molarity, concentration of B 0.100 molarity. Reaction is this: A plus B gives you C. Concentration of A in molarity, concentration of B in molarity, and the rate in molarity per second. Anyways, this?
Mm-hmm.
Now, there's no tricks in this class, yes? I give you a problem and I tell you it's on the test, yes? Do you expect to calculate the orders of these things on the test and the rate constant? 100% guaranteed. Don't waste your time not studying. So what's the idea behind this? What's the idea, guys? The idea is I double the concentration, yes? And I look at what happens to the rate, yes? So which concentration did I double? I doubled this concentration from 0.1 to 0.2 here, yes? Now I kept this one the same number. Why did I keep this one the same number?
So I see if it's first or second order and do them separately.
Let's say you're allergic to the fruit. Let's say you're allergic to some fruits. How would you know what fruit you are allergic to? Do you eat them all at the same time every day? No, yes. What would you do? You eat one at a time and leave the other ones out, so the other ones don't give you anything, yes? So I want to know the effect on one of them, so the other one has to be constant. Because if it is constant, it might be changing, and then I don't know if the change is because of this one or because of this one. So when you double one concentration, what do you do to the other one? You keep it constant.
Okay.
Okay? Yes or no? So what I did here is I left this concentration the same while I double this one. Yes? Now let's write the rate law for this. What's the rate law? Come on, what's the rate law? Violeta, what's the rate law?
Okay.
Go ahead, you say K times what?
Bracket. A. Concentration. A. Concentration of A.
Raised to
And
a power, yes?
and-
And power. Concentration of B raised to another power. Very good. That's the rate law, yes? We are trying to find the rate law. What are we trying to find from the rate law? We're trying to find this, and that. Yes? Because I have the rate. Do I not have the rate? Look, the rates are there. Do I have the concentrations? The concentrations are there. What I need is 3 unknowns. How many equations do I need to solve for 3 unknowns? This is math stuff, yes? How many equations do I need to solve for 3 unknowns? 3 equations, right? Okay, and I have 3 equations. 1, 2, 3. Okay? We're gonna do it first the intuitive way, and then we're gonna do it the right way, which is a mathematical way. You got issues with both. So, from point 1 to point 2, what happened to the concentration? It doubled. Does the concentration have the exponent on the top? Yes or no? Does the concentration have an exponent on the top? Yes. The rate does not have an exponent on the top, yes? So the concentration is the one that has the exponent. What are we going to call this? M or N?
That's N.
If it's
It is the exponent on which one?
B.
On B. And which one is b here?
B.
N. So I am going to put, because it's the exponent on b, and b is this, it has the n on the top, 2 to the n. And I look at what now?
Rate.
I look at what happened to the rate. What happened to the rate? It stayed the same. Okay? Well, how do you know it stayed the same? Well, you look at it with your own eyes, and what you see is that this number divided by that number gives you a 1, yes? And what do you have to raise this to what power to get 1?
0.
To the 0th power. So n is equal to 0. Now that's the easy way of doing it. Some of you don't like it that way. We're going to do it the right way in a second. Next one is, I use these two, yes? Now what do I look at? I look at the other two that changed. This one with this one. Did it not double from here to here?
Mm-hmm.
It doubled from here to here. Now what is the other thing I have to look at? That it stayed the same from here to here. Yes? Does it stay the same from here to here?
Yes.
Yes, so this one drops out. What happens if I use these two? This one doubled here, but when you come here, what happened to this? It changed too. And because it changed, you can't use those numbers. Okay? It changed. You can use the numbers because you don't know if the change is coming from B or from A. So while one doubles, the other one has to stay constant. But let's say that you did not have one of these numbers here. Let's say that you had no choice but to use these two numbers. How can you solve this problem? Well, you already know that from here to here is going to give you what? Okay, from here to here, the exponent on this was what?
0.
0. So from here to here must be
1.
0. And from here to here, the ones that are not here, they're going to be 0. Because you know that they're going to be 0. When you do this calculation, you already know that this will be raised to a power, yes? And you will take that into account there. That's a tough one for you. Okay, let's do baby steps, okay? So, which two numbers am I going to use to find A?
The first and
The first one and the last one. I'm going to use the first one and the last one because the first one doubles, while this one stays the same, yes? So I'm going to say, since it doubled, I am going to use 2. What was it that doubled? The concentration, yes? The concentration for which one? For which letter? For letter A. A is raised to what power? Power m. And that is equal. I look at the rate. I divide this by the smaller number. Okay? What is it? 16 divided by 4. How much is it? 4. So that increased by a factor of 4. So m must be
Second power.
2. Okay? That's the fast way of doing it. The mathematical way is by writing equations for this and dividing one equation by the other so things cancel out. Did you ever do this in math? Because I did it in math, okay? So don't tell me you didn't do it. So what I'm going to do is I'm going to write rate and I'm going to give it a number. Okay? Because this is, let's say this is experiment number. This experiment number 1, experiment number 2, and experiment number 3. If I divide rate, let's call it R, let's not call it rate. If I divide rate 1 by rate 2, what do I get? What? If I divide rate 2, here's rate 2 by rate 1, yes? This is rate 1 divided by rate 2. If I divide this by this, I get for A, I get 1, yes? And for this, what do I get? Rate 1 divided by rate 2, what do I get? I don't get 2, yes?
No.
So what do you always do? You always divide the bigger number by the smaller number, so you get a whole number, yes? It's not just divide whatever you want, and it's not going to be on the test rate 2 by rate 1 maybe, because I give you 5 of them to confuse you, because I'm spending a lot of time. Which rate am I going to divide? First, I'm going to divide rate 2 by rate 1, because this is the bigger number, divided by the little number, so it gives you a number greater than 1, yes? So this is incorrect here, but it's only incorrect because of those numbers, yes? So rate 2 divided by rate 1 is what I'm going to do. I'm going to do the whole equation, yes?
For concentration A, you made it equal to 4 because the rate was 4 for...
No, no, no. What concentration of A? This is not concentration here. This
Where,
is rate.
where did you get the 4 from? You made it equal
The
to
4
4.
is 16 divided by 4.
Okay, cool.
So R2 divided by R1. R2 is equal to a rate constant K times the concentration of A raised to what power? The M power. Concentration of B raised to what power? The N power. That was for rate 2. I'm going to do it now for rate 1. Still K, yes? Here's the rate law. Still K. Still the concentration of A raised to the M power and the concentration of B raised to the N power. I'm going to write those numbers in, but before I do that, this is the rate constant. Is it the same for experiment 1 that it is for experiment 2? Yes, that's why they call it rate constant, because it's constant. Okay? So this stays the same. Unless you change the temperature, the rate constant stays the same, so write that down. Rate constant changes with temperature. I'm going to plug those numbers in, yes? Which one is rate 2? Tell me the number. Or rate 2. Nice, which one is rate 2? Here's some experiment 2. This is rate 2. 4.0 times 10 to the minus 5. I'm going to divide this by rate 1. Yes or no? Which one is rate 1? The same one, this one? Oh, the one on the top. Okay, which is? 4.0 times 10 to the minus 5. I know what you tried saying, okay? It is the same molarity per second and molarity per second. The K's canceled out. I am going to do the concentration of A now for which rate? For the rate 2. What is it? Here's the concentration of A for rate 2, 0.1. Is that raised to a power? Yes, the power is M. What's the concentration of B for rate 2? Rate 2, concentration of B is 0.2. Raised to what power? N power. I'm going to do the same now for rate 1. What's the concentration of A for rate 1? Here's concentration of A. Here's rate 1, it is 0.1. Is that raised to a power? Yes, the power is M. Now here is the same number raised to the same power. What does that do? This cancels out. That is why you left this constant, so it could cancel out. It has no effect on it. Now what is the concentration of B for rate 1? Here's concentration of B for rate 1, 0.1. Raised to what power? The N power. So I do this. 4 divided by 4 is 1. And 0.2 divided by 0.1 and raised to the same power, it's equal to 2. Raised to what power? The N power. So now you know that N is equal to 0. What way did you like it better?
The first way. Hands
The
down.
first way you like it better?
Yeah.
Because you like whatever is easier?
It's just more straightforward. Yeah.
Let's work. Okay.
Yeah.
I want you to do this. Maybe this is, you should do it like this in the MCAT or the PCAT or the whatever CAT you are going to take. Because this is fast, yes?
Mm-hmm.
And this requires you to understand stuff. And this is the right way, okay? That's the mathematical way. I want you to learn it both ways. If you try me, I am going to grade your test by hand, and if you don't have it that way, I'm going to take off points. Yes? So, let's do it for the other one. What's the other one? How do I find the other one? Guys, you never did this stuff in math? You should be used to this. You never did this? Have you taken math?
I hope so.
What? I think this is called algebra. I'm not sure, but yeah. This is algebra, yes? It's not trigonometry. I don't think it's trigonometry. It's not calculus 1, not calculus 2, not calculus 3 or 4. This is algebra. So you did this, I remember doing this in high school. What grade? Probably 9th, 10th grade. Before that, I have no recollection of what happened in my life. So, what happened to the other one? What am I going to divide? Rate 3 over rate 1. Rate 3 over rate 1. Why do I divide rate 3 over rate 1? Because these two stay constant, while this one did what? Doubled. Very good. So, rate 3 divided by rate 1. I'm going to write the same thing again. I am just going to plug in the numbers that belong to those rate now. Okay, the k's cancel out, do they not?
Yes.
K's cancel out because they are the same and the temperature was not changed, yes? So, what's rate 3?
16.
Very good. 16 divided by 4 times 10 to the minus 5. The rate cancels out. What is the concentration of A for rate 3? Concentration of A for rate 3. Here's A, yes? Here's rate 3, that's that number. So 0.2 you said. Is that raised to a power? Yes, the n power. And what is the concentration of B for rate 3?
0.1.
0.1
Went to the end.
to the n power. We're going to do the same thing for concentration of A for rate 1. How much is it?
0.1.
0.1. And the concentration of B for the first rate. This is going to cancel out with that. Okay? And what you are going to have is 16 divided by 4 is how much? 4 equals to 2 raised to the n power. So n is equal to 2. As we all understand, you like it the easy way, yes? That took 25 minutes. This took, well, when you understand this very well, this takes 5 seconds to do. If you can do some math in your head, it takes 5 seconds. I want you to learn how to do it both ways, okay? Now, how do I find the rate constant? What? Okay, yeah, that's right. I already know m and n. All I have left is k. Which rate am I going to use from there? Let's use the first rate. Okay? We use the first rate because the first rate comes first. So we are going to say that r is equal to k. A raised to what power? I already know what power rate is A is raised to. What power is that? Second power. Concentration of B raised to what power? To the 0th power. Okay? I have rate, I have concentration, so I'm going to solve for K. So rate is equal to, I'm solving for K. You divide by the concentration of A raised to the 2nd power, divide by the concentration of B raised to the 0th power. That is equal to K. Yes or no? Which rate am I going to use? The first one, but you can use all three. Or you take an average of all three, or you do whichever one of the three. So let's say that this rate is the first one, so let's say this is, let's do it separately. So K is equal to the rate, which is 4.0 times 10 to the minus 5. Units are molarity per second, divided by the concentration of A raised to the 2nd power. What's the concentration of A for the first rate? 0.1 raised to what power? Second power. Concentration of B. It is 0.1, but raised to what power? Zeroth power. So this is equals to 1, yes? So all you need to do is, this molarity down here, this concentration was raised to the second power. Yes or no? So this is molarity to the second power. Calculate it and give me what units you get. 4 divided by 0.1 squared.
You get 4.0.
Huh?
You get 4.0 times 10 to the negative third molarity to the negative 1, seconds to the negative 1.
What?
Molarity to the negative 1, seconds to the negative 1.
So 4.0 times 10 to the minus what?
Third.
To the minus 3.
Yeah.
This molarity cancel with one of these, yes? And I have molarity to the minus 1, seconds to the minus 1, yes? Because the seconds is on the bottom. Is that the unit you expect for what order?
Second.
That is a unit you expect for the second order, and this reaction is second order. So let's write a better rate law, okay? More complete rate law. Rate law would look like this. R is equal to K. What's K? K is 4.0 times 10 to the minus 3 molarity. Molarity to the minus 1, seconds to the minus 1, yes? Times the concentration of A raised to what power?
Second.
To the second power. That is the rate law. Because now I found K, and I found the exponent. B is to the 0th power, so we can say this is 1 and just omit it, or you can write it in, okay? Yes or no? This is a rate law, that's a rate constant. What else is the problem asking for? So it's asking what is the rate at some crazy concentration, yes? What do we do to find the rate at some crazy concentration?
Plug it in.
So the rate is equal to 4.0 times 10 to the minus 3 molarity per second, inverse seconds, times the concentration. What concentration of A did they tell us? 0.050, and this is molarity, yes? I'm not going to put it inside the parentheses, I'm going to put it outside. This is raised to what power? Second power. Molarity is also raised to the second power, I'm going to write it there. Yes?
Why don't you just put it as molarity inside the parentheses?
Because I like it outside.
Okay.
It means the same, guys, yes or no?
Yep.
But some of you are going to get confused with not squaring things inside the parentheses, okay? So, 0.05 squared, that's a number, yes? I don't know it from the top of my head. Molarity squared. And B, what do I write for B? Well, B is 1, yes? So, I'm not going to write anything. So what does this give you? 4 times 0.050 squared.
I get 1.0 times 10 to the negative 5th molarity per second.
1.0 times 10 to the minus.
5
And what are the units?
molarity per second.
Here's, how do I do this? How do I do this?
You go like pa 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 pa.
If you're
They're multiplying,
multiplying, so you add them.
You add the exponents? Okay. You know them.
Yes.
I don't know what you know. I mean, minus 1 plus 2 is 1, yes? Very good. Molarity, and second still on the bottom, it's gonna stay on the bottom. Those are the units on rate, yes? Okay? Do you want one like that on this test and on the final exam?
Yeah.
You got it. No way to avoid this, okay? I've never written a test in which that was not part of it. So don't confuse yourselves, okay? We're not gonna do another one, unfortunately, okay? That's it. I may do another one more difficult, like a lot more difficult later on. Not today. Today's an easy day.
Yay.
What else would you like, guys?
The test scores.
Test scores. I'm planning on not giving you the test. I'm still thinking about what to do with this test. I'm amazed how good you guys are, but just kidding, okay? I'm proud of you. I am gonna give you a test at the end of class. It's not the end of class yet, right?
Nope. Really?
Why do you want the test so bad? Huh? Just speak for yourself. You're selfish. You don't care what you think. We want to know what we got. And she's asking, when are you going to give me my test? I'm going to return everybody's except yours. Okay. All right. How do you know when you have to find the rate law? It is asked. In the problem, they ask you, what is the rate law? If it's not being asked what the rate law is, more than likely you are going to use the integrated rate law. Okay? When you have changes in concentration, you will use the integrated rate law. When you want to find out the time it takes for a concentration to change, you're going to use the rate law. Yes? Okay, we're going to do a few problems, so don't worry about it. Look how difficult this problem is. A pollutant is introduced into a lake that stays at 12 degrees Celsius all year round. Of course, this is a lie, yes? 12 degrees Celsius. It's a lake in Canada, yes?
Yep.
Certainly not here. Here's like
More like a river, probably.
30. Yeah, probably. So all year round, a pollutant was introduced all year round with a concentration of 5.0 times 10 to the minus 7 grams per centimeter cube. So you put something on the lake, and maybe you want to kill the fish, maybe you want to kill the plants, maybe you don't want to kill anybody, and you're just dumping illegally on the lake, yes?
Mm-hmm.
So you introduce this pollutant, and that's the concentration it has. Of course, the pollutant will decompose over time, yes? So let's say if the rate constant is 1.45 that
Years to
Calculate.
-1.
calculate the concentration.
Yeah.
Calculate the
For
concentration
reciprocal years.
So seriously,
the following year.
February 29th.
This is more or less what you expect on this test, okay? How many of these do you expect on the test? From 5 to 6 of them.
1.
I'm saying, I'm telling you, from 5 to 6. Not one. Okay, not one. So, when you read the problem, you are very confused, yes? You get lost in understanding the problem, and then some of you start visualizing a lake at 12 degrees Celsius. And then you start visualizing what pollutant can somebody put in the lake. That's not nice. Blah, blah, blah. Yes? Some of you are confused with this.
The year
thing
to
here.
the -1.
Year to the -1. Basically, we don't care about anything, okay? All we care about is, what is it that you have here? This is asking about concentration,
Mhm.
and they gave us an initial concentration. So how many concentration is that? 2. One initial, one final. Yes? And then it's giving us a what? No, not a constant. It's giving us a rate constant. And when it gives us a rate constant, what topic of chemistry is this? It's called kinetics. And when you have kinetics, this is about rate laws and integrated rate laws. This precisely is about integrated rate law, because you got 2 concentrations and the rate constant, integrated rate law. What is this number here? This is a rate constant, yes? And the units on this rate constant are what?
First order.
Inverse time, yes? And inverse time belongs to what order?
First order.
First order. Because the rate constant for first order are
Seconds to -1.
seconds to the -1, yes? But this is still time to the -1, yes? But seconds would have been a large number. It doesn't matter, somebody tried to trick you. So this tells you here, this tells you that it is what order? First order. Because it is first order, every time you see a problem like that, you are looking for the rate constant so you can find out what order it is. Of course, if I tell you the order, then you don't worry about that, right? But I'm not going to tell you the order. So it's first order. What's the equation for first order?
The one with ln.
By the way, here's the rate law for first order. What can I do with this? Does it have final and initial concentration here? I can't use the rate law. I have to use the integrated rate law, which is integrated over time, yes? It has time. That's why it's integrated.
So it's
So first order is ln of AT is equal to minus KT plus ln of A0. Everybody has to memorize these equations. If you bring a cheat sheet and I catch you, it'll be the end of your career. If you write it in the back of the calculator, it will be the end of your career. If you write it on your legs and you're a girl, I will search for you, right? All right, so what am I going to do? Do I have this number? What's this number called?
initial concentration.
Initial concentration of the stuff you put in the lake. It could be a pollutant, or it could be something you injected onto yourself, yes? Right? You injected something on yourself. And what's the final concentration? Is what we're looking for. So we're looking for this. Do I have the rate constant K? Yes, I have the rate constant K, because it says rate constant, there's a number. Do I have the time?
Yes.
Where is the time? Because I don't see it.
Oh, you know it's 1 year.
It says the following year. And I am guessing that when they say the following year, that must be
1 year later.
1 year. 1 year later.
So
That's
1
what
year
the
worth.
following year means.
1 year worth of seconds.
The following century means
100.
20 years?
100 years.
100, a century is not 10 years?
Oh.
What's 10 years?
Decade.
Oh, very good. At least you guys know that. Okay, so I am going to plug the numbers in. This is how easy this problem is. That's why I'm going to give you 6 of them.
Okay.
So minus, yes, the K, 1.45 inverse year, yes? Year to the minus 1. And I am going to multiply that times what? 1 year. And what's going to happen to the year to the first power and the year to the minus 1 power?
They cancel.
They're going to cancel out, and that number will evaporate into thin air. Plus the ln of the initial concentration. What was the initial concentration?
5.0 times 10 to the negative 7.
Okay, very good. 5.0 times 10 to the minus 7. And grams per centimeters. Okay, very nice. So you do all of that and tell me what you get. I did it 10 years ago. So ln of A at time t, which happens to be a year, is minus 15.96. Check if that's what you get. Guys, you passing around the attendance?
Yes.
Minus 15.96.
Yeah.
Is that what we get?
I got minus 13.
I don't know, you weren't here last class, you wouldn't understand.
I was
Hey,
going
Diego.
Huh?
I was going YouTube.
You just go on
I was
YouTube?
going YouTube.
Don't say that.
Whose class are you gonna watch on YouTube?
Mike Christensen.
Who?
Mike Christensen or
Who's that?
some guy that teaches
I watch a really cool guy called Pedro
I think it
Garcia.
was like
AP, when you multiply in the beginning,
Well, shit.
it's -1 and
Get negative 16. This is make a whole lot of sense.
I don't think he's gonna teach you about putting stuff in your calculator, man.
no, I don't know. I put
So, is this what you get? Is this the answer?
No.
Okay, yeah, that's what you get. But is that the answer to the problem?
No.
That is not the answer to the problem, that is the ln of
Yes.
A. This is not A, I want A. I gotta get rid of this ln. How do you get rid of that ln? E to the raised to that thing would just be AT, and I do it on the other side, e to the minus 15.96. How much you make a mistake on the test and you don't remember to do the e, and the answer will be there, and you will get it wrong.
probably.
How much you bet? People do it all the time. E raised to that, what does it give you?
1.2 times 10 to the negative 7.
Units on this.
Ooh. I assume it's the same thing they give you. But
Okay, this is complicated for some of you, yes? Because you are like, what is the ln of grams per centimeters? What is it? Centimeter cubed, yes, this is centimeters cubed. Did I put centimeters cubed before? Yeah.
Yeah.
What is the ln of grams per centimeters like? What is your ln? Well, we don't know what the ln of this is. Anyway, because we took the ln and then we did the e to that power, what happens to that? It just becomes the same unit you had to begin with. Okay? And the unit for concentration was grams per centimeter cubed. If you take the ln of something that you cannot take the ln of, but then you do the e to that, it will be whatever unit it was before. Okay? So this is a concentration. Cake. Problem is cake. If this were second order, what would be different about this? The equation would be different, and that's it. Of course, the units on the rate constant are different too. When you take pills, do they have orders, these pills you take? I don't mean like drugs, I mean like, yeah, like drugs, but not recreational drugs. Not the ones that make you happy, but the ones that make you better when you're sick, yeah? Do they have orders?
What's gonna happen? I assume.
You assume. Like, let's say penicillin. You ever taken penicillin?
Allergic to it.
Let's say you take some type of antibiotic. Most of the time, the antibiotic has a half-life, let's say, of 2 to 3 hours. Yes? When they tell you to take 2 or 3 pills per day, how do you know how much you have to take per day? Is that a calculation, or is that something that the doctor tells you only he knows because he has divine intervention? It's a calculation, yes? And the calculation comes from where? The calculation comes from the integrated rate law, guys. Make no mistake. You want a problem like that?
Sure.
No?
Yeah, it was one of those really cool.
Some of you don't like drug antibiotics. You want cocaine? Cocaine better? Marijuana, weed. You want weed? You gotta tell me what you want.
The previous problem is. I don't think I can get this in my computer.
Okay. And then you take it out of that.
Okay, let's do another. Tell me when the class is over so I give you the test next class, okay?
Something weird.
Do this. right? Then
So you have to
times-
multiply these guys, right?
No, we do 1, negative 1.45 equals the answer, right? You get a number, 11, and you get a mark.
This, I'm telling you, my calculator sucks.
You should be wondering, you
Is inject with a J or with a Y?
J.
well, in Spanish it's with a Y, G-Y.
In Spanish it's with a Y, okay? So don't be judging people.
Yeah, me too.
Because you multiply this with this. You multiply them, this is a negative, and you have a 1. So these
Call it a
ones-
chemical.
yeah, right. And then you just don't have this times.
Well, it's just so
With a concentration
bro, do you even calculate it?
of
Should
2.00
ask my calculator.
molarity. Yes, 2.00 molarity. The rate constant is this. Calculate the concentration
It's a drug you inject. So I'm gonna be funny.
after
I don't know anything about drugs.
Is that
You
87?
can make heroin.
Excuse me?
Is that 87?
Yes, it is. The concentration after 0.010 seconds. Tell me, what do we do?
So you would have 2 molarity as initial concentration, right?
Okay, 2 molarity is the initial concentration because that's what you injected yourself with, yes?
Mm-hmm.
What other thing is in here?
You have time.
We have time, and the time is that.
Mhm.
And we have, what?
Wait, what's the?
What is it?
The first order.
Inverse time. It
And
means
you also have the constant.
this is called the rate constant. Here are the units on the rate constant. What order is that?
First order.
First order. It is first order, so I'm going to say this is first order, yes? And this is going to be simple from now on. The tough part was understanding the problem, yes? Because I'm pretty sure you can plug in the numbers in the equation if you memorized it right. Or you wrote it on your Scantron and I didn't catch you, right? But I will look for it.
So what gave you the intuition to use the this rate law?
The unit of
The units on the rate constant.
Well, yeah, I get that would be first, but I mean if it's going to be just rate law or integrated rate law.
It could never be rate law,
Never?
because the rate law does not have time in it.
Oh, yeah, okay, good.
Okay, so what do we do? Well, this is easy. I want the concentration, and here is minus K, which is 87 inverse seconds. And I will multiply that times the time, and the time happens to be in the same unit. So that cancels out, plus ln of A0. Where is A0 at? What's the concentration? 2.0.
I think we should have 50 of these on the test.
What?
I think we should have a lot of these ones on the test.
You will, but they'll get a little bit harder, okay?
Yeah.
We just like to warm you guys up a little bit before we give you the hard business. So ln of AT is what? Minus 0.1769.
Wow, I hate this calculator.
Is that the answer?
You have to.
That's the answer to that, but is that the final answer? No. The final answer, AT, is equal to E to the minus that, yes? To the minus 0.1769. So the final concentration is 0.84. Units on this.
Mole.
Same units that were used before, molarity.
What are you saying, 366?
What?
You're saying 366?
Doesn't matter, 0.84. That one up there has 2 sig figs, so it doesn't matter.
I didn't put the negative.
You watched the video already of that guy on
on
YouTube?
the last one.
I've been watching my videos on YouTube. Okay. We're gonna do one next class. What time is this class over?
15 minutes.
9:30? Next time, we're gonna do a problem on shelf life. What was that? Shelf life. Do you know what shelf life is?
Yeah, how long the product can stay.
You know, a bottle is put into the thing for, and they have an expiration date, yes?
That's cool.
The expiration date most of the time is 95% purity. So it's 100 the first day. When it's decreased, the concentration has decreased to 95. That's called shelf life, okay? We'll do some of that next time.